Today we are still continuing with cube, square, cube and their roots. And in this section we are going to find the square of a number by column method. When we are going to find the square of a number by column method, we are going to use x square plus 2xy plus y square or a square plus 2ab plus b square. You must be wondering how this formula comes. So let us do an activity at home. You take a square paper of 3 or of 5 centimeter or of 8 centimeter. If you take a square of 8 centimeter, divide the square into two parts, one into 5 centimeter and one into 3 centimeter. On the other side, 5 centimeter and 3 centimeter. So if you divide it, you will get one square of this will be 5 square, that is represented by a square, and another rectangle you will get 5 into 3, that is AB. 5 into 3, AB, that is 3 square is represented by B square. So we get the formula A square, AB, and B square. So this comes A square plus 2AB plus B square. If you take it of 5 centimeter whole square, then you can divide it into 3 and 2, 3 plus 2. If it is divided into 3 plus 2, then you get it 3 square, and you get it 3 into 2 rectangle, 3 into 2 rectangle, and 2 square here. So we are representing by A plus B, so we get it A square plus 2AB plus B square. If it is formula of minus, then here we get it x square minus 2xy plus y square. This is how the formula comes. And in the next part, that is, we are going to show you how deduction comes. Let us see how the deduction comes by using this formula, how we can get the square of a column number. You can open the exercise and then I will show you and you can do it at home. Students, please open your exercise 3.2. In exercise 3.2, question number 1a, 34 square. We are going to find out 34 square by the method, column method. You use the formula of column method, x square plus 2xy plus y square. So x, you represent this 3 as x, 3 as x, and 4 as y. So x square is 3 square, 2xy is 2 into 3 into 4, 2 into 3 into 4, and y is your 4 square. So 3 square comes 9, 2 3s are 6, 6 4s are 24, and 4 square is 16. So here comes this 10 place, the digit in the 10th place will come here in the x square, 9 plus 2. And the digit in the 10th place of y square will come in the here, 4 plus 1. Here with 9 you will add 2, and with 4 you will add 1, and 6 will remain as 6. So 4 plus 1 is 5, and 9 plus 2 is 11. So the square root, the required square root, square of 34 square is equals to 1156. This is by column method. To find the square of a number by diagonal method, exercise 3.2, question number 2a, consider the number 43. You draw a square and make it all diagonal of the square and write the tens digit here 4 and unit digit here 3. Here again you write as it is square, tens place as 4 here and 3. So 4 4s are 16, you write 0 here. 4 3s are 12, you write 0 here. 4 3s are 12, you write 0 here. 3 3s are 9, you write 0 here. Now, in the next box, what you will see is that 0 is 0. Now here, 0 plus 16 plus 0, 0 plus 16 plus 0. And the next is 12 plus 0 plus 12, 12 plus 0 plus 12. Then 9 comes here. So 0 remains as 0. 0 plus 16 plus 0 is 16. 12 plus 0 plus 12 is 24, and 9 remains as 9. If you do not write also, it is okay. But here the digit in the tens place will be coming here, transferred, and the digit in the tens place will be coming here. This digit in the tens place will be coming here, and the digit in the tens place will be coming here. 0 plus 1 is 1, 16 plus 2 is 18, and the unit digit will be writing here, and this 9 will be writing here, the unit digit will be writing here, the tens place is added here, and here the tens place unit digit will be writing here, and the tens place is transferred here. So 1, 8, 4, 9. Therefore the required square of 43 according to the diagonal method is 1849. Once again I repeat, to find the square of a number by diagonal method, you consider exercise 3.2, question number 2a, 43, 4 and 3 is the unit place, 4 is the tens place, 4 is the tens place, 3 is the unit place. You make it diagonal all in this way. 4 4s are 16, you write 0 here. 4 3s are 12, you write 0 here. 4 3s are 12, you write 0 here. 3 3s are 9, you write 0 here. In the next step, what you are going to do is that this 0, you write it here. 0 plus 16 plus 0 here. 12 plus 0 plus 12 is here. And 9 is here. Now, 0 is 0. 0 plus 16 plus 0 is 16. 12 plus 0 plus 12 is 24. 9 remains here. Now, one digit of the tens place of this addition comes here. This digit of the tens place 2 comes here for adding with this number, and this 4 goes down, 9 goes down. So 16 plus 2 is 18. The digit of the unit comes here, and the digit of the tens place come here, 1849. Therefore, the required square of 43 by diagonal method is 1849. The next part of our chapter is to find out the square root. There are different methods for finding out the square root, but today we are going to learn how to find the square root by successive subtraction of odd numbers. Successive subtraction of odd numbers. So you open your exercise 3.3, question number 1, B, number is 49. 49, we are going to subtract all the odd numbers, successive odd numbers. First odd number is 1, 49 minus 1 is 48. The next odd number of 1 is 3, 48 minus 3 is 45. The next odd number of 3 is 5, this 45 minus 5 is 40. Then 40, the next odd number of 5 is 7, 40 minus 7 is 33. The next odd number of 7 is 9, 33 minus 9 is 24. The next odd number of 9 is 11, 24 minus 11 is 13. The next odd number of 11 is 13, 13 minus 13 is 0. So here comes the ending number is 0. So how many times we have subtracted? 7 times we have subtracted. How many odd numbers we have subtracted? 1, 2, 3, 4, 5, 6, 7 odd numbers we have subtracted. Therefore, the required square root of 49 is 7. Let us come to the next question. Question number 1C is 121. I am doing it again because you may find it difficult. So what is the square root of 121? By successive subtraction of odd numbers. So 121 minus first odd number is 1. 121 minus 1 is 120. The second odd number of successive odd number of 1 is 3. 120 minus 3 is 117. The successive odd number of 3 is 5. So 117 minus 5 is 112. Next odd number is 7, 105. Next odd number is 9, after subtraction 96. Next odd number is 11, after subtraction you get it 85. Next odd number is 13, after subtraction you get it 72. Next odd number is 15, after subtraction you get it 57. Next odd number is 17, after subtraction you get it 40. Next odd number is 19, after subtraction you get it 21. Next odd number of 19 is 21, 21 minus 20 is 0. So how many successive odd numbers you have subtracted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 successive odd numbers you have subtracted 11 times. So therefore the required square root of 121 is 11. The next method to find the square root by prime factorization method. You open exercise 3.3 and question number is 3a. 529 is given, number is given 529. The factor of 529 is 23. You divide it, 23 into 23 is 529. So 529 is 23 into 23. So 23 into 23 makes you 23 square. So root over of 529 is root over of 23 square. Therefore, the square root of 529 is 23. Another example I'll give you, that is 256. The factor of 256 is 2, 128, 2, 64, 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. So the factor of 256 is 2 into 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 2. Here 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, 3, 4, 5, 6, 7, 8. So make it pair 2 square, make it pair 2 square, make it pair 2 square, make it pair 2 square. So it becomes 2 into 2 into 2 whole square. So 2 into 2 into 2 into 2 is 16 square. So therefore the required square root of 256 is 16. I hope students you understand and you can do it the latter part of your all the questions. Thank you. To find the square root by long division method, question number 4a, I have taken you from your book the number 841. For long division method, from the right hand side, you take a bar of double digits, and if one digit is left out, you just make a single bar over that single digit. Now, for that single digit, you try to find out the number which is equal to or less than that number. 3 3s are 9, we cannot do it because 9 is greater than 8. So what we will do is that we will do with 2 2s are 4. Because we cannot do it 2 3s are 6 or 2 4s are 8 because it is a square root method. We will have to take the same number. If you take 2 here, you will have to take 2 here. If you take 3 here, you will have to take 3 here. 3 3s are 9, we cannot do it because 9 is greater than 8. So what we will have to do is that 2 2s are 4. Now subtract it. 8 minus 4, 4. Unlike division, we cannot take out only one number. We have to take down both the numbers. 41, you have to take down both the numbers. Next step is 2 plus 2, 4, or 2 2s are 4. You have to take 2 plus 2, twice the number of this number. So what is the twice of 2? Twice of 2 is 4. Now whatever number you want to take here, you have to take here also. If you take here 9, why we are taking 9? Because here is 1. We know it that 9 9s are 81. So 9 9s are 81, 8 in hand. 9 4s are 36, plus 8 is 44. So here no remainder. Therefore the required square root is 29. Therefore the required square root is 29. Another example I'll take for you, question number 4b, that is 1156. You pair the number and take a bar. Pair the number, take a bar. Pair the number, take a bar. Here 11. Before it was single digit, here 2 digit is here 11. So by what number you can make it square? 3 3s are 9. We cannot do it by 4. 4 4s are 16. 16 is greater than 11. So we have to do it by 3. 3s are 9. So 11 minus 9, 2. You cannot bring down only 5 here, but you have to bring down both the numbers together. 5 and 6, 56 you have to bring down. Now double of 3 is 6. 3 plus 3, 6. 3 plus 3, 6. Whatever number you will have to put here, you will have to put here also. So what is the last digit? 6. What is the last digit? 6. So what we can do? We can try it with 4. 4. 4. 4 4 is up 16. 1 in hand. 4 6 up 24 plus 1, 25. So therefore, the required square root is 34. I hope you will understand. Thank you.
Stay home, stay safe, do it for yourselves, do it for your family, do it for India. Let's break the chain of COVID-19. Hum hum ye kamyab. Jai Hind.